Hello and welcome to Math 8, Unit 1A, Lesson 1. Today's objectives is scholars will develop an understanding of the nature of rational and irrational numbers. So first I want to start off talking about the real number system, and we're going to go a little bit more in depth on this in the next slides. But the first of the smallest little circle here is called natural numbers. Natural numbers are your counting numbers. So think about when you learn to count things. 1, 2, 3, 4, 5. So those are your natural numbers. Then we have a larger circle. Notice that natural numbers is inside it. All the natural numbers are part of the whole numbers. But whole numbers also includes the number 0. 0 is not a natural number because we don't count 0 things. I'm not going to look and say, oh, look, there's 0 cats. I'm not going to count them because there's no cats there. So 0 is called a whole number. So whole numbers are all the numbers 0, 1, 2, 3, 4, 5. Keep going on forever and ever. Okay, then we have integers. Integers are all the whole numbers and their opposites. So now we add things like -1, -8, -500. All of those are integers, plus still 0 and all the other whole natural numbers we talked about. Then we have rational numbers. Rational numbers mean they're made up as a ratio. They're made as a ratio of two numbers, some number over another whole number or integer. So all those are rational numbers. So that includes things like 5/8, 2/3, -2/7. All of those are rational numbers. We sometimes write them as decimals. As decimals, they always either end or repeat. So rational numbers are part of something called real numbers. But there's another category in real numbers. If you'll notice, over here we have this other big circle in real numbers called irrational numbers. So that is sort of our new thing today. So irrational numbers include things like pi. We've used that before. The square root of 2. No number times itself gives me 2. So the different rational numbers, there's an irrational number called e that has to do with logarithms. There's an irrational, like the square root of 10 is an irrational number. Okay, so let's go on and really talk in more depth about these. So this is your vocabulary. You should be filling it in on your sheet. So again, natural numbers. Natural numbers are your counting numbers. 1, 2, 3, 4, etc. It doesn't matter how big the number gets. If it is a positive whole number, even 5,273, that is a natural number. Next, we have whole numbers. Whole numbers, remember, it's all of the natural numbers plus the number 0. So this is where we add our number 0. Then we have integers. Integers are all of those above them, all of the whole numbers, all the natural numbers, plus their opposites. So now we have the negatives. This is where the negative numbers come in. Remember that all of those go into another category called rational numbers. So it's all numbers that can be represented as a ratio or a fraction with integer numerator and denominators. So you can't have a decimal in it. Decimal representations of rational numbers will always terminate, end, or they'll repeat. So I might say like 0.25, or I might say like 0.3 repeating. Okay? And remember, the other thing is irrational numbers. Irrational numbers are real numbers. I'll talk more about what real numbers are that cannot be represented as a ratio of two whole numbers. Decimal representations of these will never end or repeat. So if you look at pi, it never ends or repeats. 3.141592653, and it just keeps going. I have that up on my board. I can point it out to you guys later if you want to see it. Okay, another one, like I said, is e. E is about 2 point something. Then we also have things like the square root of 5. There's no number times itself that give me the square root of 5. If I put it into my calculator, it'd give me 2 point something, but it would never end. Things like the square root of 100 are not, because that is 10. Okay? So that is not an irrational number. Finally, we have real numbers. So real numbers are a number that can be placed on a number line, even approximately. These irrational numbers can go on a number line. We just put them about where they go. So, again, this is the real number system. You guys know that there is some space out here, so there is something that's not real numbers, which if you have a question about, you can ask, but you don't have to know it this year. But when we talk about what number category they fit in, we typically go with the smallest category. So if I asked you what number category the number -8 went into, well, it is not a natural number, it is not a whole number, but it is an integer. So we start from the smallest ones and work our way out. So that one I would say is an integer. Same thing, what if I gave you 9/3? Well, that's definitely a rational number, but it's also 3, which means it's also an integer, a whole number, and natural number is the smallest category it fits into. So make sure when you're doing your work, you're thinking about the smallest category each number fits into. If you have any questions, come see me in class. Talk to you then.